A yellow square with side length 1 is divided into 9 smaller squares, and the middle one is colored blue, which we can see here. Then each smaller yellow square, of which there are 8, is divided into 9 smaller squares, and the middles are colored blue. If this process is continued indefinitely, what is the area that is colored blue? This is a very interesting problem, and if we were to continue doing this forever, we've got the first, second, and third steps, but you could keep going, coloring more and more of the insides of these little squares blue. The resulting figure you'd get is a fractal, which is actually something that's covered in Math 70 in Math for Liberal Arts. And this one in particular is called the Sierpinski carpet, which I will write out now. Sierpinski, Sierpinski carpet, if you want to Google it. Anyways, we want to know what the total area is that is colored blue. And so I want to look first at the blue that we get in the first step, and then the blue that we get in the second step, and then the third step, etc. So here we have one square that's colored blue, and the area of that square is going to be 1/9, because the total side length of the largest square is 1. So that means the side length of this smaller square is 1/3. And so the area is 1/3 times 1/3, which is 1/9. Next, we are looking at the next squares, and there are 8 of them, these slightly smaller squares. So there are 8 of them, and the area of each of these smaller blue squares is going to be 1/81. Because if this length is 1/3, then the smaller square has a length 1/3 of that. 1/3 times 1/3 is 1/9. So we've got a square that has dimensions 1/9 times 1/9, and that gives us 1/81. Then, if we look at the next iteration, we have, remember there were 8 of these smaller squares around the edge. And in each of those, notice that there are 8 new tiny blue squares. So in this third step, we have 64 of these very tiny blue squares. And each one has dimensions 1/27 by 1/27, because they're each 1/3 the length of the previous blue square. Now 1/27 times 1/27 is 1/729. So each of these represents the amount of blue that's added in the individual step. And the question is, if this process is continued indefinitely, what is the area that's colored blue in the end? So what we need to do is we need to find the sum of this infinite series. Now, I'm going to simplify things here. 1 times 1/9 is 1/9. And then 8 times 1/81 is 8/81. And then 64 times 1/729 is 64/729. And the process goes on and on forever. And I'm going to claim that this is an infinite geometric series. Now, we know that the first term is equal to 1/9, but the common ratio here is going to be 8/9. If you look at going from one term to the next, the common ratio, the thing we multiply by, is going to be 8 in the numerator and 9 in the denominator. The reason we're multiplying by 8 in the numerator is because in each step, the large blue square that was added in the previous step gets 8 smaller blue squares around it. And we can see even in the next step, each of these Medium blue squares from the second step have 8 smaller blue squares around them. So each time the number of squares that we're adding gets multiplied by 8. And then the denominator, the common ratio is 9, just for the denominator. We're multiplying by 9 each time, because each time we look at another type of square, the area becomes 1/9 as small, because the side length is 1/3 as small, and 1/3 times 1/3 is 1/9. So this gives us an infinite geometric series, and because the common ratio is 8/9, which has an absolute value less than 1, we know that this will not diverge, and we can use the formula for the sum, which is a over 1 minus r. In this case, a is 1/9, and then r is 8/9. So we've got 1/9 over 1 minus 8/9. Now 1 minus 8/9 is 1/9, because 1 is 9/9. 9/9 minus 8/9 is 1/9. And 1/9 divided by 1/9 is 1, because anything divided by itself is 1. So in the end, the total area that is colored blue is equal to 1, which is the area of the original square in its entirety. So as we go through this process over and over and over again, the amount of yellow is decreasing so much that it is effectively asymptotically approaching 0. If we were to continue this forever and ever, there would be no more yellow area and all of it would be blue.